Okay, well, today we're going to continue talking about circles and segments in circles, and we're going to focus on what happens when they interact and how long they are. Um, Last time we talked about tangent segments and diameters, and so we're going to start today talking about chords. Chords are special segments like this segment that exist inside of a circle. They start and end on the circle like that one does. Diameters that go through the center, they're chords. They're just special chords because they go through the center. So whenever we have a diameter, like this diameter, and it crosses or intersects a chord, like this blue one, we have a couple things that happen. You can see that we get a right angle. And the other thing that happens is that this chord, this blue one, gets cut in half. It gets bisected. And so both of those pieces are the same length. They're congruent. So this piece is 13.7. That makes this one 13.7. And these facts help us find missing lengths. You're probably already seeing it and probably already dreading it. This is a right triangle. We know two sides, so we can find the missing side using Pythagorean theorem. So just another way that right triangles pop up, even when we're talking about circles. Remember that C is the hypotenuse. It's across from the 90. I'll make XA and 13.7b. And I'm not going to go through solving this. I'm just going to go ahead and tell you that x is, let me calculate it. It's about 6.58, we'll call it. If you need help solving that, please just let me know. Raise your hand, ask for help. I just figured this is something we've done now for a little while, so hopefully you're used to it. What I want you to do is just get used to, in this lesson, get used to seeing that this is a diameter and it intersects a chord. And so the things we know about that is that we have a right triangle or a right angle, and we know that this chord gets bisected, so those two pieces are the same length. They're congruent. So this piece right here is 18. That means that one is 18. And again, we have a right triangle that exists because of that right angle. And we can find the missing piece because we know this side and we know this side, and we can use Pythagorean theorem. X this time is our hypotenuse. And again, I'm not gonna work this whole thing out. I'll calculate it for you and tell you what you get. You should give it a shot. Make sure that you keep up the skill of dealing with squares and all that. You get approximately, we'll call it 20. So again, this one maybe is a little less going on. This happens even if we have a radius. A radius is just part of a diameter, so we still get that right angle. And so we could set up Pythagorean theorem. In this case, 18.8 is across from my 90, so that's my hypotenuse. And we don't have to finish this one out. What I just want you to know is that this relationship exists. When a diameter or a radius crosses or intersects a chord in a circle like this, or like this, we have these two unique scenarios. We have right angles that get formed, and this chord gets bisected. Actually, what we can call this is a perpendicular bisector. So this diameter is considered a perpendicular bisector when it intersects this chord. It makes a right angle, cuts the chord in half, bisects it. Perpendicular lines make right angles. Bisectors cut things in half. This diameter is a perpendicular bisector. This diameter is a perpendicular bisector. This radius is a perpendicular bisector. It makes a right angle, and it makes those two pieces equal. So let's get away from the right triangles, and let's look at another relationship. So here I have two chords intersecting. I have this like teal chord and this, I don't know, We'll call it burgundy, even though it's probably not. And neither of them are diameters. They're not going through the center of the circle. And so we have this special relationship that exists. And it's a bit like when we had the special scenarios in triangles, not to bring up triangles again, but the special scenario where we had proportions in triangles. And so what we have is a proportional relationship that exists between the lengths of these pieces. So each piece is cut into two, or each chord is cut into two pieces. They're not equal. You can see this maroon one or burgundy one is 9 and 8, those two pieces. And we get this situation where we have proportions. And what we did in the triangles is we drew a line and it became fraction bars. I can sort of draw a line through here, and I have a fraction 6 over 8, and I have a fraction 9 over x. And we can cross multiply 6 times x, 9 times 8. I can divide both by 6 and find that this missing piece here is 12. It's not the most technical thing. I don't have a relationship really, other than we have these proportions that we can write. So if I look here, I have two chords. I can and I can draw this like line any couple of ways, just whichever way feels natural to you to draw it through that intersection point, so that we can get fractions. So you can draw the line this way, red, or you can draw it this way, blue. Your proportions will look a little different, but you'll end up getting the right answer. So let me show you how the proportions look depending on which color you did. So red, I'd get x over 20, and I'd get 9 over 10. If I did it in blue, I could get 20 over 10 and x over 9. No matter which way I did this, when I cross multiply, I'm going to end up with 10 times x, and I'm going to end up with 20 times 9. And so I'm going to get 10x equals 180. Divide both sides by 10 and find that missing piece is 18. Let me do one more. I'm doing them all this time. I'm going to draw my line right here. So I get 12 over x and 6 over 7. Cross multiply. Divide both sides by 6. And we get 14. And I wonder if you notice this. There's another way to look at these problems, and you just choose the way that you like best and then stick with that way. So if I look at this line in my solving, you can see that 6 and x come from the same chord. 12 and 7 come from the same chord. So another way to do this is to not even write a proportion and just multiply the pieces from each chord. So I'm multiplying the two pieces from my purple chord, multiplying the two pieces from my green chord. That will exist every single time. If I look here, 10 times x, well 10 and x came from the same chord. 20 times 9, 20 and 9 came from the same chord. So we could actually skip the part where we write fractions. You might not like that, so you should stick with writing the fractions. You might not like the fractions, so you can just use that idea. Again, when I get to this step, 6 times x, 6 and x were both the parts of this chord. 9 and 8 both came from the other chord. So there's two ways to look at this, two ways to use the relationship, the way that they interact. You can sort of skip this part where you write the proportions. If you like the proportions because you like to be able to draw the line and see where the fractions are and that helps you, you should absolutely do that. If either or both of those is difficult for you and you want some help with it, you should of course raise your hand. Let me know, and I'll be glad to come help you. Make sure you stick around and you answer the problems associated with these four circles. Use the ones that I showed you as examples to help you. If you need help, I'm willing to help. When you're done, you should definitely practice. This is just the beginning of your learning these ideas. So make sure that you do some practice. Always ask for help when you need it. Do these problems. Good luck.